Check it out. What is yeah, like
Като превентира, си помисли кое от всичко смисъл кое да сме за такъв смисъл. Времето може да си критичен, да кажеш, това не ни трябва да повториш нещо друго, може да кажеш, защото други неща, които могат да поправиш. Супер! Аз търпя критика всякак.
So maybe to start the session, so I'm happy to be here and to chair the session dedicated to urban digital twins and artificial intelligence. So I'm a professor at the Gate Institute at Sofia University. So Gate is a partner of Digital Twin City Centers and Chalmers. We are working together on developing digital twins. And you already see the potential of digital twins to solving urban problems and to model environment. Now we are going deeply. We will show how the digital twins could be combined with artificial intelligence in order to gain more value and to accelerate decision making for the citizens. So we have three presenters. Mila Koeva from University of Twente, Yuinan Yu from Chalmers Industry Technique, and Nicolas Wern from UEO. Sorry for the pronunciation, but yeah. So we will start with the first presentation of Mila Koeva.
Okay, let me see how it's going to work. I'll put it in an easier way. Okay, so do you hear me? Yeah? Okay. Good. Good afternoon, everyone. Thank you very much, Desi, for inviting me here, for presenting. I hope you're not very sleepy because it's afternoon. We had so many interesting presentations. I'll try to keep you awake a little bit more. So my name is Mila Koeva, and I'm working as associate professor in the University of Twente in the Netherlands. And now I will show you some examples and what are we actually working on. This is better. Okay, University of Twente. It's in the Netherlands, very close to the German side of the Netherlands. It's a university that combines, as you can see, technical and societal disciplines. We have a lot of cross-disciplinary working, a lot of foreigners, a lot of international orientation. And it's a technological university with many faculties. The faculty I'm working with is the General Information Science and Earth Observation faculty. Just very shortly passing through these slides to know who we are, where we are, what are we doing. You can see that our mission is really to think of global challenges and perform local actions, to think about how geospatial information and Earth observation data can help us solve wicked problems. And we are talking today a lot about digital twins. We are also working in this domain, in this, using this, let's say, approach, and thinking how can we solve worldwide challenging problems using geospatial information and Earth observation data. In our university, we have also created this digital twin GeoHub, which I'm leading, and we have a lot of multidisciplinary colleagues within our group. All of us kind of united on working on the topic. Everybody has different background, different working experience, but we all work on digital twins. How do we approach creation of digital twins? Since I'm already mentioned that we have geospatial and Earth observation department, you can guess from this overview that we think first on sensors mounted on different platforms, creating and extracting data from the remotely sensed information that has been acquired with these sensors. Then we use a lot of AI or different automatic approaches to extract meaningful information from the generated data and capture data. And of course, we try to optimize how do we store, how do we process all these data so that we visualize our real world in a digital replica, and the difference, linking it in real time with some sensor or real-time information so that we have our digital twin. Today, I will give you some examples of what we have recently done. This is the city of an example of city of Enschede, where our university is located. And I'll give you an example. How did we start the thinking of how can we use digital twins for urban heat island? So we discussed today that one of the biggest challenges, first, how to create and collect data, how to integrate data. So we have, of course, started with this exercise. Do we see the video going or not really?
Yeah, it's moving.
Yeah, okay. So we collected open source data in the Netherlands. There is quite a lot, but you also got a lot of municipal data, which is not openly available. And this is a raster that is showing the urban heat in the city. This was the very initial stage of the project. Okay, let's see what data we have. Then we thought, okay, how can we visualize this data and play with some gaming engines so that people can see and think how do they feel when they walk across the streets in relation to urban heat. So you can see on the top side is a top view, and the bottom is, let's say, the personal feeling of walking around the city of Enschede. This was a very starting point of MSc thesis research. And then we decided, okay, let's go a bit deeper. We are researchers. Not only visualization is important, but let's do some analysis on having all these data sets. So we thought of investigating the physical equivalent temperature in relation to the urban heat based on this formula. So we integrate solar elevation, solar radiation, wind, and we try to simulate the PET or physical equivalent temperature on the city of Enschede. All this led to a development of this tool, which basically was done by request of the municipality. So they wanted us to develop something that is useful for their work. And so far, what we have done is a simulation when you add new buildings, when you add new vegetation, add new water body, or the other way around. If you remove, what would be the effect on the urban heat? You can see, if you want, everything is on these QR codes. You can see all that we have developed. So far, the output is only raster based. There is a lot of work to be done more in this direction, and we have a PhD student that will follow up on that. That was really the starting point. But the cool thing is that the municipality liked it a lot, and it was, let's say, a good start for our collaboration as a university with the municipality. Then we followed with the same municipality another case study, which is related to water. In the Netherlands, the water is quite hot topic, overground, underground. So we all deal with water challenges. So here we were dealing with, again, the development of a digital twin, so 3D model overground, 3D model underground, and integrating the sensor network related with water in the city. Also integrating data from sensors which were mounted in the basements of some private houses, which are giving the information of the water under the ground. So the aim of this research was to really prove the link between reality and virtual model, and to show to the municipality that they can control the physical world by having a digital model of the world. The idea was that we can visualize the historical data, the current situation of the water, and we can do some prediction or think of mitigation in case the water levels are rising. So this was the simple model that the student has developed. Of course, in terms of visualization, many things can be better, but what he was playing with is to visualize the exact location of the pumps and to show in real time when the water is rising, how the pump can be triggered and can start pumping the water out. So that was the exercise that we tried to showcase in front of the municipality. Now they're quite passionate to continue this research and make it and really implement it in the municipality. Let's see how this will go. Another example was also in relation to the underground. Not only water matters, but also how the roots of the trees under the ground are developing through the years, depending, of course, on the crowns of the trees and the type of the trees. This was another research that we have been doing. Again, research that was then demonstrating in time, in future, what could have been the challenges under the ground. And I must say that in this case, the precision was very important, and the accuracy that we are trying to visualize the underground and predict the future, let's say, scenarios of root of the tree's development. These were some examples so far in Netherlands, but our faculty is working quite a lot also with countries outside of Europe, not only in Europe, because in the Netherlands we have rich data set. We can do many things, but what about countries that don't have this data? So we are trying also to help using data sources that they have available to create digital twins. This is a case study in South Africa, where one of the challenges is waste management. And we have tried to demonstrate there how sensor data from the waste bin collectors combined with mobile application of that users can use and provide data together, can reach to such type of visualization. So in real time, from two different data sources, we get real-time information, which helps to produce the optimal route of the trucks in daily data collection from the waste bins. That was the aim of this study. The good part is it's implemented, so we kind of managed to help there in this process, which we are very happy that the research went into some practical application. And I forgot to say that especially in South Africa, there are a lot of illegal places where people are just leaving garbage, and this can only be collected via people with the app. Sensors are not always the only way of data collection in real time. That was again another case study for South Africa, where we were using cameras mounted on moving vehicles which are continuously collecting images, which we were automatically trying to use semi-automatic recognition so that we produce, let's say, reliable data on where the situation of the road needs repairing and where it is most urgent to send groups for repairing. So this was the color visualization. So many examples I can show, but the time is limited. One, let's say, a topic that we are very passionate about is using remote sensing data as a prerequisite for creation of our digital twin. So it's just for automatic extraction of vector data based only on remote sensing data. We've heard this morning about the speech of Jan Storter, where there is a lot of 3D models automatically generated by open data based on footprints plus LiDAR. But there are many countries that cannot afford LiDAR data. So how can we do the same thing using only images? And moreover, to extract vector information of our buildings only with images. We've tried a lot in the Netherlands, where houses look more or less like this. There were quite successful examples. But last year, we decided to do transfer learning, to transfer this automation. Bulgarian case study together with GATE, with the group of DESI. It was very challenging because in Bulgaria and Sofia, the buildings totally don't look like in the Netherlands. There are no similarities in the roofs. But luckily, we managed to train the model in a combined way so that we reached quite some successful results. Due to lack of time, I cannot demonstrate everything, but on this link, you can see the Netherlands case study and the Sofia case study virtually if you want to see more. This is another collaborative research together with GATE, again on a Sofia case study, where we use generative design for creating and simulating walkability and how we can stimulate people to walk more if there is more greenery. Here, automatically, we generate many scenarios, and only several are, let's say, the optimal one proposed for the designers, where they have to rethink about new areas and how to design them. A lot of research related to automatic 3D model generation by UV data, by aerial data, and so on. I will not go too much in details. I saw your sign. I'm done. So that was from our side. I have many more examples, but the main takeout is that we work a lot with Earth observation data automation and how to integrate all this into the digital twin applications. Thank you very much.
Thank you, Mila, for the nice presentation. Any questions to Mila? Just quick questions to be on time. I have one question. So what is the challenges, the biggest challenges in adoption of digital twins in practice? Because maybe for the research is easy to have some results, but how the adoption of the digital twin in practice can be made?
If I have to summarize in one word, the readiness level is the biggest challenge, because always depends on who are you doing this model for, whether it is for a company, for a particular user, or for governmental institution. What data do they have? What do they want to have as a result? And how do you fulfill these requirements? Are they ready actually for this? So this is very, very challenging to find the balance between what is requested and what you can provide. Sometimes we want to do miracles for them, but they are just not ready to use it. So we should lower down so that we meet the expectation and the needs of the stakeholders.
Okay, thank you again. So we move to our next presentation. Yeah. Maybe ladies first.
It's fine.
Okay. Also, our next speaker is Yuinan from Chalmers Industry Technique. I will switch. You should. To enlarge. Sorry, how to enlarge? Screen.
Yeah, that's good enough, I guess.
Okay.
Yeah. Thank you. Yeah, so my talk is gonna be about creating scalable and inclusive human-centric digital twins using multimodal data. So my name is Yinan. I'm an assistant professor at the Department of Computer Science and Engineering from Chalmers. I'm also a co-founder of a startup company called Asymptotic AI. And my research is about improving the usability of AI algorithms in real-world applications. So first, let me define what usability means in this context. To me, a usable AI system should be learnable, explainable, accessible, scalable, and testable. So least, that's a word. If you look at the initials, that's a happy coincidence. By learnable, it means that the AI system should be very easy for a new user to start working with it and achieve a reasonable competence. And explainable means that when an AI system produces an outcome, it should also provide some sort of reasoning behind it. So you know why it works, and when you know you can make a prediction of why or when it may fail. Accessible means that the AI system should provide the same functionality for people with a wide range of abilities and disabilities. So it should be inclusive. Scalable means that the AI system should adapt to different level of demands without compromising user experience. And testable means that the AI system should be designed in a way that such that it can be tested for its functionality, performance, and reliability. So you should be able to specify the requirements of the AI system. And to build a usable AI system in this digital twin context, first, we do sampling, of course, using different sensors to look around, look at the environment. And then we log this data, and then we reconstruct the world with our semantics built in to the reconstructed digital world. Oh, sorry. Right. So now we're talking about sampling. So how do we do sampling? Here, I'm providing some examples from a slightly different perspective. Here I worked a lot with a research lab called Reverie. So it stands for Resource for Vehicle Research. It's a research lab at Chalmers. They have a bunch of research vehicles equipped with very fancy sensors. So those sensors are, you can see from this picture, sorry, this is not, let me go back. Okay, let me not touch it. So if you can see from the picture, they have like some LiDAR and cameras and pose estimation sensors that is inside the car, and also radar equipped on this vehicle. So then I could drive this car around the city and collect my own data to build my own digital twin of the city. And this car is also, there's a software called OpenDLV. So that's a microservice-based software for the perception system. So for data logging and also control
inside this research vehicle. So you can read about it in this URL. And so my research involves using this car to collect data and build some sort of duplicate of the environment. So here I'm showing two examples. The first example is about road quality assessment. So we're driving on the road, and then we're collecting data using the cameras and the LiDAR in this case, and also the sensor pose, so the pitch, heading and roll of the car, and also the location of the car. And then we can use this data to analyze the road surface to see if there's something broken on the road, or if there are some potholes or something like that. A second example I'm showing here is, I think you have seen it. So it's within this context, it's about building facade analysis. So we're trying to analyze the assets on the building facade. Here, we're taking some photos around the building, and then we're building a 3D model of the building. And then we also estimate where the windows are on the building facade, and also in order to estimate the window to wall ratio for energy consumption analysis. So these two examples are focusing on the scalability. So we can just drive around and collect data, and then we can build a 3D model with the semantics built in. And that can scale to the entire city, right? As long as we can drive around the city. All right, so now I'm switching to a different project where I'm focusing on the accessibility of AI systems. In this project, our mission is to build safe mobility and design for all, leaving no one behind. So the objective here is to build inclusive and accurate traffic monitoring systems for people with reduced mobility. So people with disabilities, they don't feel the same level of safety when they move around in the city. So what we want to do is to provide the same level of safety for these people. And this same level of safety, this same level of safety, we mean it should be the physical safety and also the perceived safety. So they should feel as safe as the rest of us. And we also want to, of course, improve the inclusivity of the infrastructure design and maintenance. And we implement these through user studies and user journey analysis. And we are also going to use the Reverie vehicle to collect sensor data from people with varying disabilities. And we're going to develop algorithms focusing on these people. So that's the second project that I want to introduce. And we are looking for both national and international collaborators because we want to scale up the projects. So if you are interested in knowing more, or just like try to have a chat to discover some opportunities for collaboration, please contact me. Here is our team. We have a very interdisciplinary team. We have AI research person, that is me. And then we have people from social work and disability research. And then we have Anna from, so she's the project leader of the Reverie Lab. And she's originally from traffic safety research. And Christian Berger from software engineering. So he's the one building the software in the Reverie vehicle. And then we have user experience experts and also AI and AI infrastructure experts. So please contact me if you are interested in knowing more, or if you're interested in collaborating on these projects. And I just want to add one more thing. So if you are interested in using the Reverie vehicle to collect your own data, please reach out to Anna. So they are very interested in having more people using the vehicle for different types of applications. So If you don't know about Reverie, please just scan that QR code so you can look at it. And then under About Us, you can find Anna's email. I also included it here. All right, so that's me.
Thank you, Irina. Any questions for her? We have a question.
Yes. I'm sorry, I didn't catch the question.
Like the data sources you're using, did you also have a look at, for example, volunteer geographic information which is stored by citizens or citizen scientists?
Yeah, absolutely. So we're interested in looking at different sources. Right now, we're at that stage where we try to collect existing data sources. And so in this study, we're gonna analyze, we're gonna talk to volunteers and send out questionnaires and also talk to them, follow them throughout their daily journey to see what's inconvenient, what's painful for them about the environment. And then we're also gonna use the research vehicle to collect images and the LiDAR scans and so on to get them to be visible to the same level as the majority group. So yeah.
My question was also
Yeah.
more focusing on the direction that when you're driving around with the vehicles and focusing on numbers, it's quite impossible to get the whole city regularly updated, as it takes a lot of and
You mean in the first part? Yeah, absolutely. Yes. So so that's kind of tricky if we crowdsource the different sources, but yes, we're interested in that. Yes. So what we're interested in is to aggregate different sources as much as possible. Yes, absolutely. Sorry for derailing the question.
We'll see if we have technology with us. Speaking of digital twins. And excuse me if I'm tired. My kids were driving me crazy last night, and it's been so cold today, so I'm a little bit off my game here. Let's see if this works. Otherwise, I have to explain digital twins. But you know everything about digital twins now, right? So I think it shouldn't be a problem. I mean, I can just do it from the presentation, but now that it also messed up, right? Hold on. Let's try one more time. Otherwise, I'll just do it from. Yeah, exactly. Okay, well, this is fine. Can you hear me? Okay. Okay, perfect. Yeah, this is the vision. It's very similar to Mila's actually. Everything that she said, I'm gonna talk about briefly, but it's also where she sort of stops is a little bit where we start, right? So I hope you can follow. And again, interrupt me if you have any questions meanwhile. Andreas, I see that I usually interrupt you. So if you want to interrupt me, please do that. My background is, so my name is Nicolas Word, CEO and founder of Winio, started 4.5 years ago, a lot of background in management consultancy, worked for big companies like Volvo Cars, Volvo Group, responsible for data management and master data management, data quality as a service, big things, also in the building automation space. So that's actually my core background, I would say, that in innovation and strategy. And now it's troubleshooting laptops. So we'll see if this works. So maybe this is going to be an interesting presentation. But yeah, so let's just go into this one. Maybe this one. It's ridiculous. Okay, so yeah, this is pretty intimidating. So I've been working in the previous slide was just me showing my background, working in a lot of different industries with an ambition to try to solve or at least find out how we can solve problems in different industries, but actually combine them and compare them. Because as we heard today, everyone is doing siloed operations. and you can't really share data, but you can also not really share solutions and knowledge, right? If you have like, Stockholm is working on something, how do they share that with something working in Australia, in Nigeria, et cetera, et cetera. So I also have that global ambition, and we can see that in the next slides. But what we also created is a method and a step-by-step process where we don't start with the data. You actually start with a shared reality. So it's actually where are we doing things? Because that's the thing that we all have in common, that we are on this planet. We're actually all observing things in 3D, not in 2D. So everyone that is saying like, 3D is super flashy, it's new, it's actually much, much older than 2D and drawings and all this kind of things. And it's much, much easier to convey information. So that's where you start. And then you move across this line. And one thing, I actually don't think we talked about it too much today, is the prototype digital twin. So here we talked a lot about the digital twin, how you need to have like real-time data. But you also want to emulate reality and get that into a simulation environment. Because if you can actually simulate things and we do things virtually first that represents reality, that's when we actually implement it in reality, we sort of know if it works and how it works. And we need to make that explainable not to other systems and be stuck in the technical interoperability stuff and all these kind of things. We have to make it explainable for decision makers, for 5-year-olds, 10-year-olds, 99-year-olds, whatever that might be. Otherwise, we're not going to get the impact, we're not going to get the decisions. So that's why we can't show this stuff, but we can show stuff that is coming maybe in the next slide, if I can get it to work. Not this slide, the one after this. So, because this is actually important as well. And I think like we heard in one of the talks that start with purpose, I have outcome, but it's basically the impact that we're after. That's where we need to start and reverse engineer that. So that's one thing about this slide before, that's starting with the impact and the outcome. So basically, Daniel and Ward 2006 wrote something about how to get the impact from IT investments, and they have a benefits-driven framework. So you start with the impact. You understand, okay, what actions do we need to take to realize that impact? Where is the information? And then you sort of like end up with the data, right? But usually a lot of researchers, a lot of people that are in technology start with the data. Maybe they can turn the information, maybe into some insights, but then it sort of stops because you need the money and all this kind of thing. So starting not from here, but actually from the top, and then also looking at different, even if you can connect systems together, technically, it doesn't really matter when you're working with AI because, it's basically like everyone here needs to agree on one language. Maybe we have Esperanto, but that's the big problem with you talking about AI and API economies, that you have 20 different systems, all talking different languages. You want to bring them together in an interoperable platform, but when you work with AI, you need to understand what everything means. And all of them speak different languages. So that's semantic interoperability challenges, but also you have the organizational, like we talked about today. The energy side, not talking to property side, water side, healthcare, et cetera, et cetera, et cetera. And you need to do that. And the way that we've done it is very, very similar to what Mila said, in the sense that working with, this should be an animation. Let's see if this works. This one moves. The left one is about going in and visualizing 200,000 cell towers in the US. So basically the zoom out approach, so that you go to the entire planet, you should be able to see to zoom in, how to visualize 200,000 cell towers in the US, and also visualizing in extended reality, augmented reality, so that you can go out to a cell tower. You can take your phone or smart glasses and look up to the sky and you see the network coverage, right? It's not just data, it's not just something, you can actually see these things before you. And that's also what we see here, very small. I can move this baby. So this is a digital twin from Seattle. Oops. Where we have exactly this zoom out, zoom in approach to, again, zoom out to the entire planet, you zoom in, you agree to a shared reality, which in this case is Seattle, bringing in then GIS data. So we get information from fiber cables, cell towers, energy, real-time SOS calls, and basically just creating a shared view for all the different stakeholders that are actually working in this area. But today they're not talking and they're not communicating, they're not working together, and they can't really understand each other. But when you approach it like this perspective, they have an understanding of what's going on. And then it's also the interesting part here, which I sort of understood today, is that even though the technical interoperability challenges are not sort of working together, but people can actually understand this, right? So it's less about AI as an artificial intelligence and actually leveraging human intelligence and artificial intelligence. Because that's also the problem with AI, that it's still data scientists, right? And data science today, when they approach a project, then they have to study about the domain. But you can't really get to know understanding 30 years of domain experience in 3 months. And then you have to work with domain experts. So it's basically this extreme collaboration approach. And where Mila's sort of stopped, I think, is again where we take over with the real-time data, being able to do this in a global space. So this company, I'm on the board of directors, they call DDX Technologies, and they have an XR orchestration platform. So let's say you have these solutions in Seattle, and then you can take it, and then you can apply this basically anywhere on the planet as well, and also visualize. I don't know if you've showed that in augmented reality. You can sort of see it, in VR, XR, mixed reality. So what we see here is, and this is probably I'm gonna wrap this up a little bit as well, is coordination. And this is important, especially for not just, again, getting stuck in analysis paralysis, but actually getting out in the field and doing the implementation work. So what we see here is someone just doing this for either their phone, iPad, glasses, whatever, and being able to collaborate and coordinate this from somewhere else. So right now we're in discussions with IoT or smart meter deployments in India, for instance, where they're deploying 25 million smart meters, going for 200 million smart meters. And the biggest problem is not access to technology, it's actually collaborating with people on the ground. So again, you have someone on the ground, they see this, and then someone over here just drops down something in front of their eyes and basically, move over here, this is where you need to be. And if we saw like the presentation before the keynote, if you also then have CTGML, the digital models as the baseline, you can really orchestrate this, again, on a global level instantaneously. So I think that's really interesting when it comes to this collaboration perspective. And again, interrupt me if I'm going too fast. So the zoom out, zoom in approach is also, so for my company, this is one of our customers, what you saw, or I'm on the board as well. But we also developed something which I can't show because the video is still loading. Let's see if I can. Let's see if we can show something. Or if it's too heavy. Oh, it's still loading. Okay, I'll have to walk you through it. But in Växjö here in Sweden, my company won this innovation tender a couple of years ago. 1 and 1. It's been painful, so I'm not really sure that was winning, but they were after a smart heating system. So existing assets, is a school, what you see is this one, where they basically had no information. They had some drawings going back, a long time. We had to create the 3D models, turn them into IFC models, BIM models. And then, also here we can see in Unreal Engine, but we developed, the hardware, the actuation capabilities, software, distributed intelligence, and also collaboration to, it completely disappeared. So anyway, but you should be able to see this, where it's also coupled with real-time data. And what you also see is that you can zoom in and then hide different layers so that you can look at the heating system, the ventilation system, all in real time, right? And because it's XR, it becomes pretty interesting because you can also be there in front of the school and just see these beams of light that you saw, and you can immediately get an understanding. It's warm over here, it's cold over here, here's a sensor that we need to change, all these kind of things. And then again, experts can help out in collaborating with this, wherever you are on the planet, basically. You have to have like the speed and latency, of course. Okay. Let's see if I can. It's hidden, but I'll remove it. Now this is dead. Let me see, just to like explain this one, the next one, or we can just wrap it up. So then the next one over here, the very small one, which is bigger in real life, is again just showing augmented reality. So again, combining real-time data with augmented reality and also with speech conversation. Because that's a big problem right now for installers and field technicians. That's taking a phone, doing things, and then writing stuff down. But what we're seeing right now and also in the next couple of years is that you're just wearing smart glasses, and then I would just be looking around. This would scan the entire room, and then maybe you do an installation, and then you probably press record when you come in, and then that also updates the digital twin, right? Because that's a big problem when it comes to the real estate lifecycle. The big question is, okay, we have these IFC models, we have the BIM models, we have the 3D models, but when the building is changing, what kind of processes do we have to keep the digital twin up to date? And that will be, that is easy if you know what you're doing, but it will be even more mainstream. It will be easier, again, with wearables, all this kind of stuff. So if there's something with all this information, I think like it's working with AI and getting them to understand the context without digital twins in this project, especially during the pandemic, would have been impossible. So because we started with this, where are we on the planet? We're in VECA, taking the 3D models, agree to a shared reality, and then we can sit around digitally so with the the asset in the middle, and we can have principal, technical asset manager, IoT person, data scientist, working with real-time data, and again see, okay, what happens if we change this? And then everyone can sort of see, okay, this is what happens, right? And that immediate feedback loop, not only from the real world, but also from all the different people working, that could otherwise take 6 months to 1 year, or it takes 5 minutes. So I think that's the benefit of digital twins, that you can try things out in a virtual environment first, and then knowing that it works, and then everyone agrees, and then you do it. Okay, questions, comments? Thank you so much. And this was super impressive, like, just so you. But yeah. Comments or questions?
Question, Nicholas?
Thank you so much.
Yeah, I can, I have a question. Yeah, I'm thinking with you wrote the autonomous AI agents, stuff like that. What are the thoughts about that, to have these kind of reasoner agents in a system who play around with the reason capabilities of large language models?
Yeah.
So you drop language in there as well.
Yeah, exactly. It's on one of the slides. No, I was with the presentation how to make large language models small. I think that's where we're heading right now. So there is a language model basically in the school. The AI that we've developed, which is also different from, I think, like most traditional approaches, is that it's not cloud native, it's edge native. So it's pure distributed intelligence with incremental learning, random forest and decision trees, which basically means that you drop in the sensors, the AI is there, and it predicts what will happen based on the real-time data. So you don't need any access to any historical data. So the next step is exactly what Andreas is sort of talking about, for us at least, to work with something called actor-based modeling and multi-agent systems, so that you turn basically everything in the building, the people, the different systems, as in the heating, ventilation, air conditioning, the individual sensors, the actuators, even the BIM models, so that here's a building, or sort of like here's a component of the building, what assets there are, and trying to get them in a multi-agent system, and basically tell it to run through all the different variations and the combinations that can happen with this building, and then see what happens, right? And then you come to a point, okay, now when we know sort of all the different variations, we have that intelligence inside the building, and then that means that you work with federated learning, and that's also the benefit of working with edge native digital twins, is that instead of sending all the data from all your buildings up to the cloud, you're just sending 1% of the data. And that 1% is not just analytics, it's actually insights that have been already proved in the building, right? So maybe this is a little bit complex, but that's like definitely the next step. And I think right now, because this is we pushed in all the data into physics-based model, so for game engines, and now with NVIDIA Omniverse and a lot of different tools, and also something called USD, Universal Scene Description, you can actually apply tools much, much easier to this context, right? So I mean, that's sort of what we're doing in the next step, and I think that's what a lot of companies will do as well. And if you don't know about NVIDIA Omniverse, I recommend checking out, their keynote presentations, and also USD, if you're working with the 3D models. And if you're not working with edge native intelligence, I also recommend that, because cloud native is just such a big cost and such a big waste. So try to solve problems where they happened, and not just try to bring analytics out and try to figure out what will happen. Is that an answer? I mean, it is an answer.
Yeah, we cannot take the discussion further. I think, there's a lot of stuff that happened quite quickly now.
Yeah,
So I saw you have the ontologies under also, it's like connecting the.
Yeah, you need a structure for all the information. Yeah. So the structure, just briefly, is the ontologies provide relationships, and then taxonomies provide the hierarchical infrastructure. So you want to bake this into something that makes sense, so that AI can sort of like work with it. So we're working with graph DBs, vector DBs, and sort of like different databases in order to get this stuff done, because there's no really one size fits all, not yet at least. But yeah, let's talk about it. Okay.
So thank you very much. Thank you for all presenters. So I'm closing this session, and we can continue our discussion during the break.
Okay.
Thank you.
Thank you.
Yeah, it was. Yeah. But this is where you all went. Yeah. Yeah. No, but not the actual simulations. Yeah. Yeah. No, but let's talk about it. Maybe we're really